Children, young people, countrymen. Here we go. Lesson 65. You're going to learn today how to write equations of parallel and perpendicular lines. We're going to have sets of lines. We're going to see whether they will continue on in the direction they're going without ever crossing, or if they are at 90-degree angles to each other. So this is going to be some y equals mx plus b kind of stuff. That means that you are going to need a pencil. Where's my pencil? This is the pencil. And place to write down notes. You're going to need your homework paper. Print some more of that junk off. You're going to need your graphing calculator. Probably today, it wouldn't hurt. You're going to want to have some of this type of paper or stamp. They sell them for like $5 at Office Depot. You're going to need a corner reflector. Don't ask me where that came from. And if you get kind of stressed out, then the Slinky is the thing for you. Sorry, let's get with it now. Let's talk about a few details. There's a couple of things that this is going to lend itself to later on. If you're taking geometry next year, definitely you want to understand what we're doing today. And so we're going to be talking about how this overlap between algebra and geometry happens, and it's called coordinate geometry. It's putting triangles and lines and things on a grid and talking about parallel and talking about angles and talking about shapes and types of angles and triangles. So that's one thing. And this is all going to kind of relate to something you'll learn about later. You'll get to know this guy Euclid and something that's called the Fifth Postulate. Very important. We won't go into much of that today, but I just wanted to kind of make you aware of that. Key today to working out some of these problems, we're going to change the form of equations so that we can put them in slope-intercept form. And then the trick today for determining whether two lines are parallel or perpendicular is to compare their slopes. That's what the M stands for in mx plus b, slope. And then we're going to learn to play a little game. I call it the negative reciprocal game. It is fun. It's fun. You're going to like it. Notation. Parallel. You're going to have two vertical lines like the L's in parallel. Or, as I've often done it, is like this, two kind of slanty lines, but they're the same slope. So that means parallel. And parallel means same slope. Identical slope, same M's. And then this thing here, this like upside down T business, means perpendicular. Perpendicular means that right there is a 90-degree angle. 90 degrees to each other. Perpendicular. Or another word that you might see sometime in math is called orthogonal, which I really like, but I try not to use that too much. I don't want to scare you too much, although I'm going to scare you. Game time. Now, to get to the crux of parallel, perpendicular, really perpendicular, because parallel is easy. If two things have the same slope, two lines have the same slope, they are parallel. I'll show you that on the other camera here in a couple of minutes. But if we want to indicate, we want to find out if two lines are perpendicular or not, and we compare their M's, their slopes, we need to have two slopes that have different signs. One has to be positive, one has to be negative, and we're going to be looking for reciprocals of each other. Different signs and reciprocals of each other. So one of the skills we're going to learn is how to write the slope, how to write an equation of a line that is perpendicular or parallel to another line. So let's imagine that the slope is 2. That'd be easy if it's parallel. It'd be 2. That would be a parallel slope. But perpendicular, we would have to change the sign, and then we're going to have to flip that fraction upside down. Now 2 is the fraction 2 over 1. If we're talking about rise and run or changing that y over change in x, we're going to turn that fraction upside down and turn it into 1/2. These slopes are at 90-degree angles to each other. Negative 3/4, it's negative reciprocal. First, negative of a negative is a positive. And then the reciprocal of 3/4, 4/3. Those two, if there are two lines with slopes of negative 3/4 and positive 4/3, they'd be at right angles to each other. 2/3, the negative reciprocal of 2/3 is negative 3 over 2, perpendicular. And negative 7, well, that's negative 7 over 1. The negative of a negative is a positive, and the reciprocal of 7 over 1 is 1 over 7. If you can keep that in mind, you'll be able to write perpendicular slopes pretty easily, given the information. Now I'm going to move over to the other camera and work our way through a few different problems, but this is where you're going to need your XY grid paper, or at least some graph paper, in order to graph these things and understand the picture and how it relates to the equation. We've got two equations here. This one is already in mx plus b form. This one is not. This is in the standard form. So we have to put them in the same form so we can compare them. We can answer that question, are these two lines parallel? And the answer is yes, but this thing right here means if and only if they have the same slope. So this one, here's the slope already. If we change this other equation into mx plus b form and we get negative 4/3 out in the front, then the answer is yes. So let's check on that. 4x plus 3y equals 6. We've got to isolate that y all by itself. So I'm going to move this over here first. 3y equals negative 4x and 6. And then we're going to go ahead and divide everything by 3. And I think you can see where this is going. We have negative 4x over 3 and 6 over 3, which is 2. We don't care about the plus 2. We care about the slope. This is the thing that determines if they have, if these two lines are parallel. Negative 4/3 x plus 2 and negative 4/3 plus 5. Like to see those on your graph? Okay, so here's my graphing calculator. Zoom in on that here. Got my two equations in there, and then I'm going to hit graph, and if you can see with the glare there. There's the first one. And here comes the second one. And just visually, you can tell that those two are parallel lines. Astonishing, right? Okay, well, our next example, excuse me. Our next example is to write an equation for a line that's parallel to this line, but that goes through the point 2, 3. Goes through the point 2, 3. Now, some of this you can kind of visualize here on the grid paper. You want to see where that is, maybe. Here's my point 2, 3, but then here's my line 3x plus 4. So you can see that the point they're asking about is not on this line right here, but they want it on a line that is parallel to that one that also goes through that point. So our line will look something like this where the pen is at. But I want to know exactly what the equation is for that line, and then I can compare the two of them. So let's get going with that. We have a little bit of math to do here. And I want to give you maybe like method A and method B. Method A is going to use the slope-intercept form to derive that equation. The other one will use the slope point form. So just to remind you of that, y equals mx plus b. And they've already given us enough information here to use this. We already know that, that the slope of our new line is going to be the slope of this other line because they're parallel. So a 3 would go right there. They've also given us an xy point. So my equation is going to look like this. I just don't know what b is. So that's what we're going to find. And we're going to do that by plugging in a 3 for y and a 2 for x. That's that point 2, 3. We're going to plug that in, and now we're going to solve for b, and then we'll write it in right there. So 3 equals 6 plus b. And then b all by itself will equal negative 3. So now I just go up here and I'm going to change this. Now I know what it is. And there's my equation for a line that is parallel to that line and goes through the point 2, 3. The other way is the way they suggest in the book is to take our other form, y minus y1 equals m times x minus x1. And again, I already know what m is. I know that m is 3 because they're parallel. And then I take that point 2, 3 and I plug it in. So y minus 3 equals 3 times x minus that 2. Because the point was 2, 3. And I crunch the numbers here. I get 3x minus 6. And then I add 3 to both sides, and lo and behold, 3x minus 3. I get the same thing that I got up there. You can use either method that you want to, starting with either of the forms that you want to, but either way you're going to get to those two equations. Of course, these two equations are parallel. We already know that, but let's go ahead and graph them and see. You got 3x plus 4 and 3x minus 3. And here comes the first one, and then there's the second one. Looks parallel to me. It's always good to check, though. Okay, our next conundrum is to write the equation of a line that is this time perpendicular to this line here, negative 1/2 x minus 1, that goes through the point 1, negative 3. And like before, it's kind of helpful for me to visualize this, so I've gone ahead and drawn this in. There's that point. I need a line that's going through that point, but that is perpendicular to this line here with slope of negative 1/2 and crosses at negative 1. So it's going to be something like this. Okay? It's not really great, but it gives me an idea of what kind of equation that I should get. Let's first of all play that reciprocal game, that negative reciprocal game. It's probably better to write that slope like this. And then we go, the negative of a negative is a positive, and the reciprocal of 1/2 is 2 over 1. So our equation is going to at least be like that. Okay? And we know that it looks like from our picture I did, it crosses a negative something. But we can do it like this and use that first method. And I'm going to plug in the numbers now and solve for b. So I'm going to put in here negative 3 equals 2 times 1 plus b. That gives me that b is negative 5. So that means my equation actually is slope of 2x and an intercept of negative 5. That seems to make sense based on the picture. Let me pull that up again here. So I just have to make a 2x minus 5 here and see where that is. Go 1, 2, 3, 4, negative 5, and slope of 2, which goes right through that point. And if we were to check it, we would find out that it's perfectly 90 degrees one from the other. Now you're going to have to tune in for episode 2 because I got 2 more things to show you. One is going to be this here. We're going to take 2 sets of 2 points and find out if those lines are parallel or perpendicular or neither. And then we're going to do a little bit of coordinate geometry to see, is this a right triangle?
See you soon.